Hello and welcome. This is Mr. Everett, and today's lesson is our first lesson dealing with linear expressions. Lesson's all about generating equivalent expressions by combining like terms. Let's get started. So we know so far that a variable or algebraic expression is an expression with at least one variable. But what exactly is a linear expression? Well, the best answer to that question, let's graph two expressions, x to the power of 2 and 2 times some number x. So take a minute and see if you can graph this expression. So just to help you out, this is x, your input, and you're going to square it, and you're going to get y, which is 2 squared is 4, negative 2 squared is 4. So if you go negative 2, your answer is 4. So go ahead and finish that for me, please. And tell me what the shape of the graph is. All right, so here is the final answer. And the shape of the graph, in my opinion, is a curve. Excuse my writing, C-U-R-V-E. See if I can make a better R here. V-E. So curve, right? It's not a line. What about 2x? If we graph 2x again, we substitute negative 1 here, and that would give us negative 1. So when x is negative 1, y is, I'm sorry guys, y is negative 2. I can't write today. Please that graph for me and tell me what shape it is. Okay, so when we graph that, we actually do get a line. And we'll talk about later, it passes through the origin. So in a linear expression, no variable has a power greater than 1. So this is x to the power of 1. If it's squared, third, or anything like that, it's not linear. Also, you cannot have a variable in your denominator. So even if it's to the power of 1, if you have, for example, 2 divided by x, that's not linear because you cannot have you cannot have a variable in your denominator and be linear. And also, as the name implies, when you graph the linear expression, it's a straight line. Okay, because we're going to talk a lot about linear expressions, so I want you to know what linear expression was. All right, so combine like terms. Now, we've done this before, hopefully in the 6th grade. A linear expression is in simplest form if it has 1, no like terms, and 2, no parentheses. And we'll talk about that when we talk about distributive property later on. Okay, so we're going to do a quick example here. I think that's lesson 3 or 4. So like terms are terms with the same variable raised to the same power. This is a quick review. For example, is this expression in simplest form? No, it's not, because although we don't have any parentheses, we do have like terms. 7z and 3z are like terms. Why? Because we have z to the power of 1. They have the same expression. They have the same variable to the same power, z to the power of 1. And negative 12 and 9 are like terms. They're both constants. So let's go ahead and combine like terms. Again, hopefully this is a review for you guys. If not, there'll be enough practice for you to kind of figure it out. So let's simplify linear expression. 7z, some number 7 times some number z minus 12 plus 3 times some number z plus 9. What are my like terms? 7z and 3z, negative 12 plus 9. Those are my like terms of 7z and 3z, negative 12 and plus 9. Now, I know it's read 7z minus 12, but you have to think of that 12 as a negative 12. And again, my clock has disappeared, so we're going to stop after this. 7z plus We're going to combine like terms 7z and 3z. We're going to put those two together. And remember, you have to keep that negative sign in front. So I have 7z plus 3z is 10z. And negative 12 plus 9 is negative 3. Do one more. 6 times some number n minus 1 minus 8 times some number n plus 9. My like terms are 6 times some number n and negative 8 times some number n. And my other two like terms are my constants, negative 1 and 9. I'm going to combine those two. And I have a negative 2 times some number n plus 8. Okay, we're going to stop right there because I'm not quite sure what time it is. And we'll pick this up in the next video.